Good morning. Today we'd like to talk about systems of equation and how to solve system of equations. When two lines intersect, they form a point. The coordinates of this point serve as a solution for both equations. There's an analogy that I'd like you to hear. Suppose you're driving a car, you're chugging down the road, and you come to an intersection. As you enter that intersection, which street would you be on? That's correct. You're on both streets. The intersection is common pavement. As the intersection of a line is a point, that point is on both lines because it is a common point. We'll explore three methods that will allow us to solve systems of equations. Substitution, you've heard that word before. It means when you have a value for an expression or a variable, you substitute that value. Elimination, it means, in this case, it means canceling out a term. We will cancel out one variable term and solve for the other variable, and then substitute that. Graphing is a graphical representation of a system. It allows us to see the physical lines where they intersect is a common point. That common point is a solution for both equations. I'm going to use a very simple system for my examples. Then later we'll come back with some more difficult systems that will allow us to explore methods, the same methods with different data. Find a solution to this following system. X plus 2y equals 11. And minus x plus 3y equals 14. Let's use substitution first. Remember, we're going to use the same system for every method. Our first step here would be to solve one equation for x. Well, I'm going to choose the first equation here, and we're going to solve that equation for x. When we say solve for x, we mean isolate x on one side of the equal sign. X equals. So as you look at this, and we know how to solve equations, in order to isolate x on one side of the equal sign, we must subtract 2y from both sides. Or as I say in a line game video, if this term changes sides, it changes signs. As I recalculate, I now see that x is equal to 11 minus 2y. And now that I have a value for x, I want to use that value. It's called plug and play. In this case, I'm going to plug that expression in for y in this second equation. I use the second one. I solve for y in the first one. I'm going to solve for x with the second one. It says substitute the value into one of the equations and solve for y. Well, I suggest that you use the equation that you haven't already touched. Okay. So I'm going to substitute that expression back into my second equation. Well, as we see here, the signs on the expression has changed. The reason for that, the expression 11 minus 2y equals x. As we sub in, we don't sub in negative x. We sub in x. And then the distribution of a negative 1 through this term occurs. Therefore, we have negative 11 plus 2y plus 3y equals 14. In order to solve this equation, my first step I'll take will be combining like terms. 2 plus 3 equals 5. Next, I want to move my constant to the right. In order to do that, I must add 11 to both sides. 11 minus 11 is 0, so that falls off. That is canceled out. And 14 plus 11 is 25. So I'm left with 5y equals 25. Now, I want to solve this equation for y. And doing so, it's a one-step equation. I must perform the opposite operation. What's the opposite of multiplication? Division. So I'm going to divide both sides of the equal sign by 5. And 5y divided by 5 is y. 25 divided by 5 is 5. And now that I have a value for y, I can sub back into my original expression for x, where everywhere I see y, I can sub 5. So I'm going to go back, and I'm going to substitute 5 for y. X now becomes equal to 11 minus 2 times 5. We know that 2 times 5 is 10, so x becomes equal to 11 minus 10. 11 minus 10 leaves us with 1. And the solution for our system is x equals 1 and y equals 5. The 0.15 is on both lines. If it is indeed on both lines, then it has to be a solution for both equations. Let's see. 1 plus 10 equals 11. That's truth. Minus 1 plus 15 equals 14. That's truth. So 1,5 is solution for this system. Going forward, we'll just assume that 1,5 will be the solution. We don't have to check anymore. Now, the first step for elimination, I'm going to eliminate one of these terms. Allow me to express something that you can use as far as eyeballing to see which method you should use. If you have terms that are equal and opposite, then you can use elimination. If you have a term that has a coefficient of 1, then substitution works well. In this case, we have both, but our method that we're using here is elimination. So I'm going to eliminate one set of terms, the x's or the y's. So I'm going to add them together to eliminate the x term. As I add, 1 minus 1 is 0, so they've been eliminated. Now I'm going to add 2 plus 3 is 5. 5y's equals 11 plus 14 is 25. We've been here before. And the method that we used previous, we will now solve for y. And I know that to solve for y, I must divide both sides by 5. 5y divided by 5 is y. 25 divided by 5 is 5. Next, I want to substitute my y value into the equations, or one of the equations, and solve for y. I'm going to use the first equation. I'm going to sub back in, okay? X plus 2y equals 11. So everywhere I see y, I want to put in my 5. X plus 2 times 5 equals 11. 2 times 5 is 10. In order to solve this equation for x, I must subtract 10 from both sides. 11 minus 10 is equal to 1. And here again, we find the solution to this particular system is 1, 5, or x equals 1, y equals 5. These are really easy systems. This is a really easy system because it fits both categories. I planned it that way Later we'll do some systems that don't fit both categories, and I'll explain why. Now, last, graphing. Again, we're going to use the same system, and we're going to graph this system. Okay. Our solution, as I was told, was 1, 5. X equals 1, y equals 2, 4, 5. So the solution point is there. And for that point to be a solution to both equations, it must be on both lines. In other words, they should intersect at that point. Let's see if that works out. First, I'm going to say that these two equations are both in the standard form. I'm going to solve these equations by, I'm going to graph these equations, excuse me. I'm going to graph these equations by finding the x and y intercepts of both equations. And if you recall, the x and y intercepts, when we're looking at x equals 0, we're looking at the y-intercept. When y equals 0, we're looking at the x-intercept. So the first question is, when x equals 0, what does y equal? Well, this term disappears. We're left with 2y equals 11. In order to solve, it's a one-step equation. For y, I will divide both sides by 2. In doing so, I find that y is equal to 5.5. So when x equals 0, y equals 5.5. And now when y equals 0, that's a pretty easy situation because this term disappears and I have x is equal to 11. I want to graph that. I must first remember that when something's 0, I don't go x left or right on the x-axis. I go up 5.5. Why am I going up? On the y-axis, up is positive. 2, 4, 5.5, right about there. And then I'm going to find 11 on the x-axis, which is positive, and 0. 0 means that I'm not going up or down. I'm simply going which direction on the x-axis is positive? That's correct. I'm going to the right. 2, 4, 6, 8, 10, 11. I want to graph these two. So I have a ready-made line here. I'm going to put this puppy right there. Hopefully it does. I'm just a little bit off there. The halves and the 12ths and the 11ths or whatever fractions of a unit are hard to graph. But I'll say that they cross through that point. Here again, I want to find the x and y intercepts of this equation. I first say, what do I get when x equals 0? Well, that leaves me with a one-step equation, 3y equals 14. I will divide both sides by 3. And I see that y is equal to 4.6. Another difficult graph there is 4.6. And when y equals 0, we see that x will be equal to negative 14. Okay, so I'm going to graph this other line and see that on the y-axis, the y-intercept is at 4.6, 2, 4, and let's put him right there. And on the x-axis, the intercept is negative 14, 2, 4, 6, 8, 10, 12, 14. I'm going to graph this particular line by connecting the dots with a line. And as you can see, because I am just a little bit off here with my negative, my 0.6 anyway, you can see that indeed they do cross at this point. Right here. Now, I promised some different equations, systems. So let us look into a system that can be solved by substitution. Now, as we look at it, I said you can substitute if you have a coefficient of 1. None of these variables have a coefficient of 1. However, substitution still works. And you look, there are no multiples of or equal opposite, so then it's not a candidate for elimination. However, I'm going to use this particular system to demonstrate substitution. First step. My first step will be to solve one of the equations for one variable. In this case, I'm going to solve for y. And I'm going to use the second equation and solve it for y. In order to solve for y, I have to isolate the y term on the left side. So I'm going to move the x term to the right. That means I have to subtract 4x from both sides. And as I do so, I'm going to cancel out here and be left with 2y equals 16 minus 4x. Now, in order to solve for y, I must perform the opposite operation, and the opposite of multiplication is division. So I'm going to divide both sides by positive 2. In doing so, I find that 2 divided by 2 is 1. So y is going to equal 16 divided by 2 is 8. 4 divided by 2 is 2. Y is going to equal 8 minus 2x. Now that I have a value for the y variable, I'm going to substitute that value back into the equation that I haven't touched, the top equation, and solve for x. And as I substitute back, I find that I have a distribution here. First step of solving equations is to perform all distribution on both sides. There's none on this side, so I'll perform this one. And that's negative 5 times 8 is negative 40. Negative 5 times negative 2 is positive 10. So I'm left with 3x minus 40 plus 10 equals 14. In the first step of solving this equation, I will combine like terms, which means that 13 is a result of 10 plus 3. And I have 13x minus 40 equals negative 14. Now I must move this constant term to the right to isolate my variable on the left. So I'm going to add 40 to both sides. 40 minus 40 here is canceled out. 14 plus 40 is equal to positive 26. And I say that to solve to solve the equation for x, I must divide both sides by 13. 13 divided by 13 is 1, which leaves x. 26 divided by 13 is 2, which means that x is equal to 2. Now, what that means is that my solution can be found by plugging in the value of 2 for x in this expression right here and solving for y. Y is equal to 8 minus 2x. X is equal to 2. So we get y equals 8 minus 2 times 2, which is 4. And we find that 8 minus 4 leaves us with y equals 4. And my solution set to this system is 2, 4. That point is common to both lines, so it should be a solution to both equations. Let's see. 2 times 3 is 6, minus 20 equals negative 14. That's correct. 8 plus 8 equals 16. That's correct. We see that 2, 4 indeed is a solution to our system of equations. Next, I'm going to use an equation or a system that is not in terms of x and y to solve a system. Okay, this system is not in terms of x and y, it is in terms of m and n. We have two different variables. Of course, we have here m is a candidate for substitution. However, we've been asked to use elimination. So our first step would be to multiply the second equation by negative 2 in order to eliminate the n term. Why negative 2? Well, what we're looking for in elimination is equal and opposite. In order to make these n terms equal and opposite, I should multiply positive 3 by negative 2 and get negative 6n. In doing so, I must multiply negative 2 by every term in the equation. I find that I end up with negative 2m minus 6n equals negative 8. Now the next step is to add the results to the first equation and eliminate this n term. In adding, I find that this middle term, this 6n minus 6n, disappears. 6 minus 2 is 4, so we're left with 4m. 12 minus 8 is 4. In order to solve this one-step equation for m, I should divide both sides by 4. In doing so, I find that m is equal to 1. M is equal to 1. The next step, I want to substitute the value of m back into the other equation to solve for n. So 6 times 1 represents 6 times m plus 6n equals 12. I want to subtract 6 from both sides to isolate my n term. 12 minus 6 is 6. 6n equals 6. I want to divide both sides by 6. I find that 6 divided by 6 is 1. So n is equal to 1. The solution for my system now, I find, is 1, 1. N equals 1 and m equals 1. Let's check. 6 plus 6 is 12. 1 plus 3 is 4. So that is a solution to this system. This has been Solving Systems of Equations for Mr. Ellis's Bridge class.